My name is G. Pranit. I am from CSC E section. My topic is PATHGUARD. Problem statement. PATHGUARD is a specialized security framework in database management system. It safeguards sensitive data by analyzing and controlling query paths. This system is particularly useful in environment with indirect data access. By enforcing semantic level restriction, it mitigates interface attacks. Inference attacks exploits legitimate queries to reduce restriction information. PathGuard prevents this by breaking query navigation across sensitive joins. It acts as a checkpoint for multi-step queries and views. Thus, even allowed data cannot be used to breach policy boundaries. This offers a strategic and proactive data protection mechanism. Introduction. PathGuard monitors a restricted how data is accessed through SQL queries. It prevents users from chaining allowed queries to infer restricted data. The system acts on the principle that access to part must not imply access to the whole. PathGuard focus on the logical of access rather than just permission. It analyzes query paths semantically before execution. It designs accounts for modern data privacy regulation. This includes law like GDPR, HIPAA, and enterprises compliance rules. It protects both individual records and organizational knowledge. Query logs and patterns are used to refine future protection. It's ideal for multi-user and cloud-hosted database environment. Objectives: prevent unauthorized interfaces inference of sensitive records, enforce fine grand query level access policies, block unauthorized join across data views, maintain strict user isolation in shared DB environments, analysis semantic structure of SQL before execution, reduce chance of accidental data leakage. Enable admins to define and manage secure query paths. Ensure only permitted data segments are accessible. Improve visibility into how queries are being used. Facilitate secure integration in application and dashboards. Facilitate secure integration and application and dashboard. Use case 1. Employee salaries or performance info can be inferred via other queries. For example, department average salary is public but individual salaries are private. As use cloud drive restrict info by subtracting nodes enters from averages. PathGuard intercepts such indirect inference attempts. It blocks queries based on joint patterns or result dedication risk. Access in control not only by table or column but by path logic. If it applies rules that detect attempts to connect non-sensitive with sensitive data. This ensures strict isolation even within related dataset. It's critical in HR system where partial transparency is allowed. So we take another use case. Healthcare system often provide appointment and doctor data openly. However, diagnosis and medical histories are highly confidential. Attackers may correlate appointment patterns to infer sensitive details. PathGuard secure access at a semantic level. It prevents combining patient schedules with treatment records. This blocks any logical leap from available to protected data. It complies with medical privacy regulation like HIPAA. Even unauthorized medical staff can be restricted to only their assigned patients. Query items are monitored, flagged, and logged for future analysis. We take second use case. Financial data often includes metadata like account creation data, branch, etc. Employees may try to infer balance or transaction via metadata correlation. Example, analyzing number of large transactions without seeing actual values. PathGuard prevents indirect analysis by restricting query scopes. It inspects joins that relate user profiles with sensitive fields. The system also blocks statistical interface using aggregate function. Accused rules are applied dynamically based on the data request. Sensitive columns like balance or credit limit are protected across paths. Financial institution benefits by preventing fraud and data leaks. We take in another use case. Cloud-based databases often host multiple clients, like they are called tenants. Each tenant must only access their data, not that of others. Even shared schemas or views must enforce strict access boundaries. PathGuard provides tenant-level data isolation. It applies rules that restrict queries by tenant ID or ownership fields. Unauthorized joins across tenants are automatically rejected. It helps SaaS providers enforce secure multi tenancy. Admins can define isolation policies at the schema or row level. This ensures legal and confidential compliance across cloud infrastructures. Use case 5. University portals often serve students, staff, and administration. Each group have varying levels of access to academic records. Example, staff might access student timetable but not grades. PathGuard ensure queries respect role-based policies. It checks query semantics, block unauthorized joins or filters. Sensitive records like disciplinary action or backlogs are protected. This encourages data transparency without compromising confidentiality. It also allows for secure research or analytics use for aggregating data safely. Students cannot reduce peer performance through indirect queries. Case 6. Business intelligence, in shortcut BI. BI tools often combine multiple data sources. This can result in united data exposure if queries are not restricted. PathGuard intercepts queries that correlate safe data into sensitive insight. Example, merging sales metrics with employee IDs to infer bonuses. It supports real-time validation of BI dashboards and reports. Admins can restrict queries to specific combinations of columns. It ensures reporting tools adhere to organizational data governance rules. It works seamlessly with modern data warehouses and BI platforms. Thus, it provides a layer of protection for strategic business data. Business data. Technology use, SQL parsing and structure analysis for query validation. Query optimization engine assisted in semantic rewriting. RBAC and AVAC supports for role and attribute based policies. Metadata tools for understanding table relationships. JSON and XML policies to define access rules declaratively. Integrated into popular DBMS like Oracle, MySQL, and SQL Server. Supports logging and real-time alerting features. Query logs helps in tuning tuning policies and detecting trends. Can work with middleware for application level integration. Function component 1 intercepts all incoming SQL statements before execution. Prevents direct and indirect access to restrict data paths. Semantic analyzer understands query intent, not just syntax. Access engine compares query path and policy database. Identify risk factors in joins, filters, and projection. Module integration supports microservices and monolithics alike. Allows for policy-based query rewriting rather than blocking. Maintains a balance between functionality and security. Compatible with enterprise-grade logging and metrics tools. Functional component 2. Query rewrite modifies unsafe queries into compliant ones. Login system capture every denied or modified query. Monitoring module highlights frequent policy violation. Admin dashboard provides GUI for managing policies. Real-time report helps in optimizing rules and reducing false positives. Rewriting use query templates to fix minor violation on the fly. Logging supports legal audit requirement for regulated industries. Adaptive learning features can improve policy accuracy over time. Administrative interface supports visual rule mapping. Challenges and solutions. Performance overheading. Semantic analysis at latency. Solution is use caching and shortcuts for common paths. Complexity of rules. Admins may myconfig policy, predefined templates, and UI derived rule creation. False positive. Block valid queries due to strict logic. Solution is allow rewrites and user feedback integration. Integration with legacy system can be hard to retrofit. Solution is use PATHGUARD of a proxy layer or middleware. And conclusion for this is PATHGUARD is essential for secure data operation in modern DBMS. By controlling query paths, it blocks both direct and indirect data breaches. It supports role-based, attribute-based, and semantic level control. Through semantic intercepts, they address interface and logical leaks or architecture integrate smoothly into enterprise system. Use cases span healthcare, finance, HR, education, and more. The system modularity ensures adaptability and performance. PathGuard stands out of strategic solution for data security in database. Thank you all.